All right, so in order to add standard deviations into our graphs, we're first going to need to calculate the standard deviation for each of our treatments, the straw-like mulch bags and the woody mulch bags. So kind of like before, I'm making almost like a little table over on the right. I'm just writing it above the other one so it doesn't get confused and start adding things to our graph without me wanting it to. And like average, it is a nice simple calculation in Google Sheets, just equals, and then stdev. And then parentheses, and I will select my data. So for straw-like mulch, I'm going to go down and drag and select all of them. All right, so that's our standard deviation. I'm going to go ahead and do the same thing for the woody mulch bags. Equals stdev. And then I'm going to select all of the measurements for the woody mulch bags. And to really understand our standard deviation values, we're going to want to add error bars onto our graph that show what one standard deviation away looks like compared to our mean. So in order to do that, we can click on your graph, click on the three little dots, edit chart, and then you can go into customize and series. And we want to do it one at a time because our standard deviation was different for each one. So I'm going to start with the straw-like mulch bags, scroll down, select error bars, and we're going to do a constant and enter in the number by hand here and insert the value that our standard deviation was for straw-like mulch bags. So I'm going to move this out of the way for a moment. It was 0.9273. So now we have an error bar, this line above here that is a standard deviation above and a standard deviation below. And then I can go ahead and select woody mulch bags and then do the same thing. Error bars, constant. The standard deviation doesn't calculate well when we have the average here. It will just be exactly what our mean is, which is why we need to do a constant and enter it in by hand. Let's see. For this it was 0.8314. Nope. I'm missing a decimal point. That's going to make my data horrible. Much better. All right, let's go back and look at our graphs and see what we have. All right, so now there is a bar, one standard deviation above and below the mean on both of these. So what a standard deviation tells us is how varied our data is. So this bar will be really big if our data is really spread out. If there were lots of really low measurements, like maybe this one right here, and also lots of really high measurements. There's a wide range. That means it's going to be really spread out. If these numbers were all really similar, these bars would be much tighter together. And as you can see, both of these are really big, and there's a lot of overlap. So the lowest point of this one is below the highest point of this one. What that really means is we can't be totally sure that our results are real here. They could be due to random chance. If there's not overlap in these lines, that means our difference is probably reliable and shows a real difference between our mulch treatments. But with lots of overlap, it meant we had lots of variation, and the difference in the mean could have just been by random chance. So go ahead and add error bars into all of your graphs and see if your data is statistically significant or if it could be just due to the result of random chance.